All right, guys, so today we're going to be looking at notes for 11.4. 11.4 is going to be split up into 2 different days, so we'll be looking at day 1 today. Okay, for the warm-up / skills check, I encourage you guys to pause the video and try this one on your own. Okay, hopefully you've tried it by yourself. Going through this process, if it says find the perimeter of the following triangle, just going through that really quickly, you'll end up using Pythagorean theorem. 9 squared plus x squared is equal to 41 squared. After doing Pythagorean theorem, what you'll end up with is that x is equal to 40. Okay, we've been doing Pythagorean theorem a lot, so I'm not going to go through all those steps throughout that process. But if they ask you to find the perimeter, then what we're looking at here is just adding up all the sides. Okay, so remember, perimeter means we're adding up all the sides. We got 9 plus 40 plus 41 to give us a perimeter of 90. And the units that we're looking at here is feet. So that's the answer to the warm-up. And jumping into the notes now, again, we're looking at the area of regular polygons. So to start off, we want to go ahead and identify what does it mean for a polygon to be regular. A polygon to be regular indicates that we have a polygon where all sides and angles are congruent. So for a polygon to be regular, all sides and angles must be congruent. And now we jump into something known as the radius of a regular polygon. So in this picture to the right, what we have here is a regular polygon outlined in green. And our radius, okay, let me make sure I'm color coding this here. Our radius is going to be defined as the segment drawn from the center to the vertex of a polygon, okay? So this right here can be understood to be a radius. AB is a radius to that polygon. AD is also a radius to the polygon. And here we introduce a new vocabulary word, the apothem. The apothem is going to be a segment drawn from the center to the side of a polygon. So again, a segment drawn from the center to the side of a polygon, we call that the apothem. And so one thing to note is that the apothem is a perpendicular bisector. Okay, this part is extremely important. So the apothem will always be perpendicular, meaning that it creates a 90-degree angle with that side that it touches. Okay, on top of that, it also bisects that side. So we get 2 congruent halves. And not only does it bisect the sides, but it also bisects this angle A here. So it splits this angle into 2, I'm talking about this angle right here. Splits that angle into 2 congruent halves. Okay, so again, the vocabulary we're looking at, remember the radius is from the center to the vertex. The apothem is from the center to the side. Okay, those oftentimes get confused. So let's practice just identifying these new vocabulary terms. In example 1, it says identify the following for the regular polygon below. It says identify the center. Well, the center is going to be right smack in the middle. That's going to be point G. The apothem, remember the apothem goes from the center to the side of a polygon, and it creates a 90-degree angle. It's perpendicular. So our apothem here is going to be GF. Okay, so line segment GF will be our apothem. Okay, so this guy right here. Next, we're looking at the radius. Remember, the radius goes from the center to the vertex, okay, the vertex being one of those corners of that polygon. So an example of a radius could be another radius that we have present here is going to be GE. So again, just be comfortable understanding the difference between the two. I know I've said this a couple of times already, but remember, apothem is from the center to the side of the polygon. The radius is from the center to the vertex. And so what we're going to look at now is how do I find the actual area of a regular polygon? The way that we find the area of a regular polygon is going to be by looking at this formula here to the right. So the formula we have is area is equal to 1/2 AP, where the capital A is going to stand for the area, and the lowercase a is going to stand for the apothem. And P here stands for the perimeter. So the way that you're going to find the area of a regular polygon is you're going to take 1/2, multiply that by the apothem, and then multiply that by the perimeter. So that's our formula for the area of a regular polygon. So let's practice finding the area here with an example down below. It says find the area of a regular polygon below. So we're using this formula here, 1/2 apothem times perimeter. So for us to find the area, I need to find out, well, what is the apothem and what is the perimeter? The apothem, remember, is from the center to the side of a polygon, and they actually give it to us here. And I always know that the apothem, sometimes they'll mark it in the picture, sometimes they won't. But the apothem is from the center to the side, and it creates a 90-degree angle with that side. Our apothem is 22. Now, it tells us in the directions here, find the area of the regular polygon. Okay, remember, a polygon to be regular means that all of the sides and angles are congruent. So, in this case here, if all of the sides are congruent, that means that all of the sides are going to measure 30. And so if I want to find the perimeter, I'm going to add up all the sides, but that's a lot of adding to do here. So all we're going to do here is just count up how many sides we have. We have 1, 2, 3, 4, 5, 6, 7, 8. Adding 38 times is the same thing as multiplying 8 by 30. If we multiply 8 by 30, we get a perimeter of 140. So our area formula, area is equal to 1/2 apothem times perimeter. We know the apothem, we know the perimeter. Let's plug it in. So we have the apothem of 22 times the perimeter of 240. From here, we just multiply it out. I'm just doing this by hand because I don't have a calculator. We have 1/2 times 22, which is 11. So we have 11 times 240. If we multiply that out, then we get 2,640. And remember that when we're talking about area is going to be in units squared. Our picture here has our units in feet. So the area is 2,640 feet squared. And that's it. That's how we find the area of a regular polygon. Let's look at a few more examples here. Example 3. And we got the formula over here to the right at the top right of your page. It says example 3, find the area of the regular polygon below. Okay, well, this happens to be a triangle. And in this particular figure here, we need the apothem, we need the perimeter. The apothem, they give it to us, it's 3.5. If I want to find the perimeter, well, all three sides are congruent, so if one side is 10, the perimeter would just be taking 3 and multiplying by 10 to get a perimeter of 30. Well, if the perimeter is 30 and the apothem is 3.5, well, we plug those into the formula. We have 1/2 times the apothem, 3.5, times a perimeter of 30. Okay, and you can really just plug all of this directly into the calculator if you want. We have 1/2 times 3.5 times 30. If we multiply those values out, we get an area of 52.5. And the units we're looking at here is meters, so we have 52.5 meters squared for our area. All right, next we're looking at example 4. It says find the area of the regular polygon below, okay? And when we're looking at this picture here, what I'm noticing is that they give us the side length of 16, but what they don't give us here is the apothem, okay? One thing that we talked about earlier in the notes was that the apothem is a perpendicular bisector, though. So I know that this apothem that's highlighted in blue is going to bisect the side that it connects. So this side of 16 is getting bisected and is getting cut into two congruent pieces. Well, if I cut 16 in half, well, that means each half is going to measure 8. So I don't have the apothem, but I have enough information in this right triangle to figure out what my apothem is, which I'll call x. We said that this bottom side right here got cut in half from the 16, and that's 8. The diagonal of this triangle, which we call the hypotenuse, is 17. And so we have a right triangle here where we're missing one of the sides. What we can use here is Pythagorean theorem. We can do x squared plus 8 squared is equal to 17 squared. If we work this out, we have x squared plus 64 is equal to, I believe this is 289. And from here, we'll subtract 64 on both sides, giving us x squared is equal to 225. From here, we can square root both sides. If we square root both sides, we get that x is equal to 15. So that apothem right there is going to be 15. And so we can write that off to the side here. Our apothem is 15. What we need to find now is the perimeter. Well, this is a regular polygon, so all sides are congruent. and we have a total of 1, 2, 3, 4, 5 sides. So if I want to find the perimeter, I'm going to take the number of sides 5 and multiply it by the side's length, which is 16. If we multiply that out, we have 5 times 16 to get 80. So the perimeter is 80. Okay, well, our formula is area is equal to 1/2 apothem times perimeter. So we have 1/2 times the apothem of 15 times the perimeter of 80. From here, we multiply it out. We have 1/2 times 15 times 80. We get a perimeter, I'm sorry, not perimeter, but area of 600. So our area is 600, and the units we're looking at here is centimeters squared. Okay, so again, just as long as you're following that formula, area is equal to 1/2 apothem times perimeter. As long as we are given enough information here, we can find the area of that regular polygon. So we'll finish up with these last two examples here. Example 5 says a regular hexagon has an area of 166.26 inches squared and has a side length of 8 inches. Find the length of the apothem. So we're talking about area here. We're talking about a side length, and they're asking us for finding the length of the apothem. So if we're talking area of a regular polygon, then we're talking about this formula, area is equal to 1/2 apothem times perimeter, where we can see here that the area is 166.26, so that's our area, capital A. We have a side length of 8, so a side length of 8, that doesn't tell me anything directly about the formula, but I know that I can find the perimeter using the side length. And then they want us to find the length of the apothem, so find the apothem. Well, I need to find lowercase a. So what I suggest with these word problems is list out all your variables off to the side. Let's list out what capital A is, the apothem, and the perimeter. So the area is going to be 166.26. And we're looking at the apothem. We don't know what it is. We're going to call it x. The perimeter, well, the perimeter deals with a side length of 8, and it says we have a regular hexagon. So a hexagon has a total of 6 sides. You can draw this out if you'd like. And each side length is 8. Okay, picture doesn't have to be perfect, but this at least gives me a visual. If it's regular, all the sides are congruent, so I just went ahead and marked those. So if I want to find the perimeter, we're going to take the side length of 8 and multiply it by the number of sides, which is 6. So our perimeter is going to be 8 times 6, which gives us 48. So with what we have currently, we have everything that we need in the formula. We have all of our variables defined. So let's plug everything in. Capital A is 166.26. That's equal to 1/2 of the apothem, which we are calling x, times the perimeter of 48. So if we go through this process here, we have 166.26 is equal to, well, I have 1/2 times x times 48. In this instance here, some students get confused and try to distribute. We are not distributing. These are being multiplied individually, okay? And so you can go in any order that you want when you're multiplying, just doing straight multiplication. What I'm going to decide to do here is 1/2 times 48, which gives us 24. So we have 24 times x, which is just 24x. So we have 166.26 is equal to 24x. If I want to find x, which we have labeled as the apothem, we're going to divide both sides by 24. And so from here, we're going to type in the calculator 166.26, and we're going to divide that by 24. Doing so tells us that x is equal to, well, 6.9275. And it says, find the length of the apothem. Well, we found it. The apothem is 6.9275. And the units that we're going to want to use here is going to be inches. So I'm just going to write inches underneath. Okay. It didn't tell us to round, so I'm just going to leave it as is. A lot of the times we might ask you guys to round to the nearest tenth or hundredths. But if the directions does not specify, just ask your teacher whether or not they want you to round. And so we'll finish up here with example 6. The area of a regular octagon is 151.42. If the length of the apothem is 6.76, then what is the length of each side? So pretty similar problem to what we just looked at. And for the word problems, we said, well, let's go ahead and list out all the variables. We're talking area of a regular octagon. So area of a regular polygon is 1/2 apothem times perimeter. So our capital A here is 151.42. They also tell us that the apothem is 6.76. What we don't know currently is what the perimeter is. We don't know what the perimeter is. We can call that x. The question here is asking you, what is the length of each side? Well, I know that we're looking at a regular octagon. If I'm looking at a regular octagon, an octagon has a total of 8 sides. And so we don't know what those side lengths are. But I know that the perimeter is equal to those, multiplying all of those side lengths by the number of sides. So if I don't know what these side lengths are, I don't want to call them x. I'm just going to call them y. Okay, so these could all be understood to be y. And we'll kind of come back to this picture here later. So for right now, let's go ahead and start working with the area of a regular polygon formula. Let's plug in our known values. We have 151.42 is equal to, well, 1/2 times the apothem of 6.76 times the perimeter of x. Okay. From here, we'll just multiply it out. We have 151.42 is equal to, let me double check with the calculator here. I think this is 3.38. Okay, but let's be on the safe side. Times 6.76. Yep, 3.38. And then we have times x. Well, that's 151.42 is equal to 3.38x. Dividing by 3.38 on both sides tells us that x is going to be 44.7988. So that's equal to x. And so now that we have x, that represents the perimeter. So I'm just going to write here off to the side, the perimeter is 44.7988. Okay. What they asked us to find was the length of each side. Okay. Well, the perimeter in this case is going to be found by taking y, the length of each side. So we're going to have y times the number of sides, which we have 8 sides. So my perimeter is equal to 8 times y. Well, we already know what the perimeter is. We know that the perimeter is 44.7988. So I'm going to plug that in for P, the perimeter. If we plug that in, then we have 44.7988 is equal to 8 times y. What I now have is an equation that lets me find the length of each side length, which I have labeled as y. From here, I'm just going to divide by 8 on both sides. Put that in the calculator and divide by 8. We get that y, each side length, is going to measure 5.599. Okay. It didn't tell me to round, okay, so I'm just going to leave the answer as is, okay. A lot of times, if it doesn't tell you what to round to, I tell my students to round to the nearest 10th, okay. Double check with your teacher, but if we round this to the nearest 10th, then y, the side length, would be approximately 5.6, okay. But that'll be it for the notes. Y'all's assignment is going to be on the very next page. Please go ahead and take the time to practice. If you have any questions, concerns, please feel free to reach out to your teacher.